that some of the clouds allow you to do with networking, to see that are similar yet quite different. And then I'm going to tell you what we are putting together such that you can manage these things that are similar but different in a much more consistent way from the RightScale perspective. Okay? So I'm going to start telling you something that you probably already know. Right? If you don't know, I hope that it's clear by the end of the talk. Networking is messy. And obviously not only on the physical side, but it's also very messy in the cloud. Right? And there's many reasons for which this is the way it is. One reason, different cloud providers really pick the settings and the things that they think you want to manage. Every cloud provider may think that you need slightly different things, right? So this leads to obviously different APIs, different resources, different names, and different semantics. On top of that, if you are installing your own cloud from the private cloud perspective, when you actually install the cloud, the choice and flexibility of installing it would also allow you to end up with a cloud that is really, really different. If you take OpenStack, for example, the way you configure it, it can end up leading with, in many different ways. It's OpenStack or CloudStack, but the resources that you end up exposing are quite different too. Now, layer that on top of that, the fact that clouds are not static, they change, public and private. Public clouds change APIs, they introduce new resources all the time, so they evolve. So does the private cloud software, right? So these things change. So what does this mean to you if you are a user of these clouds, of these APIs? Probably means that you have to stock up on medicine because it's going to be, headaches, hair loss. You're going to be pulling your hair. It's not going to be easy. But if you step back for a second, this mess is really not bad. In fact, it's good. It's good because it means that you can choose exactly the things that you want to use from networking. There's not a one-size-fits-all, right? I don't think that the cloud provider or a cloud software vendor can come to you and say, this is exactly what you'll need, and that applies to all of the companies in the world. So this mess, while it's headachy, it's actually a good thing to do. So we must embrace it. Right? You must basically embrace the fact that if you're using one or multiple clouds, you want to pick exactly which things fit your business. Right? So you want to embrace those power features that the different cloud providers want to differentiate against each other. But you want to do it not at the cost of losing your focus on your business. If you're not in the business of building wrappers of network APIs, then you probably don't have to have your developers have more headaches than they already have by battling those APIs. Right? So what I'm positing here is that you should, instead of grooming an army of experts within your teams that need to understand and be an expert of every single detail of these networking APIs, just let other people clean up the mess for you. Do that work so you don't have to do it. Okay? So that's where we're going with these new abstractions that we're going to present to you guys at RightScale. Right? We want to still give you the full control, right? If you want to use that specific feature of that cloud provider, you should be able to use it. So we're not watering down APIs, right? We're giving you something that you can do at a higher level, easier, while you can still go down the rabbit hole for the moments that you want to go down the rabbit hole. So another way to look at this is that I think that you probably don't want to look at your cloud networking from this perspective. You kind of want to look at it from this perspective, something that from a single pane of glass, I know what I want to do in general. I don't care about the specifics a lot of the times, but when I do, then I'm actually getting it out into the specifics. That's the idea behind. So with that, let me spend a few slides, explaining what some of the features exist today from the cloud providers themselves, private and public. I'm going to pick three just because I'm a little more familiar with them, but we could do the same thing and same analysis with any other cloud that is out there. But I think that picking these three gives us a good feeling of the different things that exist and the differences that they have. So let's start with Amazon EC2. What does Amazon EC2 provide nowadays? Amazon EC2 has, for each region that they have, like US East, US West, you can create multiple VPCs. Right? So you can have N VPCs in your account. These VPCs is basically the isolated isolation perimeter of your network, right? Everything inside is the network. If you have to communicate anywhere outside that network, that VPC, you have to go through some gateways, right? That's the only way to get in and out. That's a typical scenario. Within those VPCs, you can create subnets. There's different subnets that subdivide basically the CIDR blocks of your VPC. And these subnets have, they call them elastic network interfaces. They're virtual network interfaces you can have there, and then you can reuse. And that's the way to plug in an instance into that network. In Amazon, every subnet must be scoped to an availability zone. So your VPC can span availability zones, but a given subnet is bound to one availability zone. What else Amazon provides? Obviously, security groups. We already had that since the beginning. They have some routing capabilities also, and they have some network ACLs capabilities, kind of a firewall-like thing. The difference between security groups, for the ones that you maybe are wondering or don't know very much, security groups and network ACLs / firewalls, they're very similar, but they're slightly different. A security group is an abstraction that gets ingress rules into, you attach these rules to instances or groups of instances. While the network ACLs or firewalls are more things that you might be used to from a more of a premises perspective, that is rules that have to filter traffic across subnets. So it's similar, yet not exactly the same. So that's why I have them here separate. Okay, so basically, with all these features, you can launch instances. Remember that when you launch an instance, you launch it in one availability zone. But with VPCs, you can connect one instance to multiple subnets, as long as they belong to the same availability zone of the instance, right? So I could not connect that red instance to subnet 3, because subnet 3 is in a different AZ. Okay? So another thing that is different in VPC is that the security groups that are attached to the instance are bound to the network interface. So you may have a set of security groups attached to the interface of subnet 1, and another set attached to the instances in subnet 2. Right? So it's a bit more rich, the way you can do these things with VPC. Now, this is what's happening right now. This is what you can do right now, although you may not be using this, because there's a lot of backwards compatibility. They've put this out there in the last few months, but you may not. You can continue using the networking in the way that you've used it for the last 6 years. So that's what they call EC2 Classic. So what is EC2 Classic? That you might be much more familiar with. EC2 Classic is really a single network that is not even exported in the API. Your account has a network, implicit network, that you launch things in. And again, everything is NATed. Instead of a gateway, you have all the communication in and out goes through the NATing boxes. And it does not have any subnets. It does not have any network ACLs or routing tables. You have no control of that. But it does have security groups. And that's probably a good percentage of you guys are maybe only using this, which has been the same way for 6 years, right? So that's the EC2 Classic thing. Let's take a look at, that's what I was saying yes before too, that a given instance, because there are no subnets, is associated with a set of security groups. You cannot have multiple interfaces, so there's only one set of rules that you're bound to. GC. GC is different in many ways. Now, for example, in GC, you don't have regions. There's one single region, if you will, like the GCE cloud. But within that big cloud, you can have networks. They don't call them VPCs, they call them networks. It's the same isolation perimeter. And again, everything that has to go in and out of that network has to go through well-defined gateways. Inside that network, they don't have subnets, at least not for the moment. Obviously, this is only 1 year old, so Amazon has been out there for 6 years. So I suppose that they'll have more routing capabilities and more subnetting capabilities in the future, in one way or another. But right now, it's not there. They don't have routing tables control, and they do have something that they call firewalls. And I kind of separated here the fact that Google firewalls are a little bit like security groups and a little bit like ACLs. Because you can have tags, you can associate a bunch of rules for tags, and every instance that has that tag basically gets those firewalls things. So it's kind of a little bit straddles both ways. So that's GCE. So in GCE, you also have to launch an instance in a zone, and you attach firewalls or security group-like firewalls to each of them. Okay, the next thing is cloud stack, and I picked this as an example of private cloud. So the interesting thing, like I was saying before, is that when you getting into the private cloud, means you or a partner is installing that private cloud, and there's a lot of things that you can tweak. And I use this example as that, showing that there's really many different ways you can bring up a private cloud. So for example, cloud stack, you can enable multiple networking modes depending on what the zones. In cloud stack, you can have different zones, and each zone could have a different networking mode. One of the modes is basic mode, that they call it. It's a flat networking. It's very similar to EC2 Classic. In fact, it's modeled against EC2 Classic. So you have one network. You can have multiple ones, one for each availability zone. They call them zones. You have one flat network for the zone. Everything is NATed, and that's what you have there. Inside, like in EC2 Classic, you don't have subnets, routing control, or ACLs, but you do have security groups. So that really resembles very much EC2 Classic from that perspective. The funny thing, though, is that the security groups are not bound to the network. So for every zone, you don't have a different set of security groups. You have the same set of security groups depending on the domain, kind of the tenancy thing that you have on top. So the same security groups will be shared across the networks that are marked shared in your zones. So not quite the same as EC2 Classic. But there's other modes. That's the same thing. Remember that all this needs to be bound to an availability zone, so you cannot have instances in the same network that span zones. Okay? Advanced mode is another mode that you can put a zone in. Advanced mode allows you to create several networks also, several perimeters. Each network still scoped to a zone. And then you have, instead of having security groups, there's an option that with KVM and shared networks, you could have security groups depending on the installation. But in a sense, if you want to simplify a little bit, they provide firewalls. More like the routing, not the routing, but the rule-based type of rules. So now that's another way of doing things differently. But there's even another mode or a variation of the advanced mode that you can also install that is fairly new in the last few months, which they call VPCs, in which you can now say, I have multiple VPCs. They don't call them networks anymore. They call them VPCs. Again, every VPC is scoped to a zone, right? That's the difference with Amazon and Google. And in this case, when you install it in VPC mode, you can have subnets. You can subdivide those VPCs into CIDR blocks, all of them in the same zone. They don't have network interfaces exposed through the API, although when you launch things, you can sort of see as if they were connected to several places. And you have some control of routing tables across these subnets and obviously the firewalls. So it's kind of a bit of a hybrid of what we've seen before. Now, remember, notice that instead of calling them subnets, they call them tiers. So in Amazon, we have VPCs here, subnets there. In Google, we have networks and no tiers or subnets. So the terminology changes from cloud to cloud. That's basically it. Okay, so that's kind of a very quick, I guess, introduction of some of the things that exist down there that you can actually use from their low-level APIs. So what are we doing at RightScale to try to make sense out of these of things like this? We've defined a bunch of resources that abstract these concepts that I just showed. So you're probably used to working with images, snapshots, volumes. We have all kinds of things already in our API. Now we're introducing new ones. Things like subnets that we already had or security groups. Now, instead of being not bound by the network, now they're going to be inside a sub-resource of the networks. But like I said, the containment model is what I showed in the slides. So now we have instances, subnets, IP address bindings, which are connections between an instance and a subnet through network interfaces. We have network ACLs and routing tables. You'll see that network ACLs and routing tables are not available quite yet, so they're going to be the next things that are coming after. So let me try to paint this picture with the same sort of diagram that I was showing you before. So this is how it looks like. From a RightScale perspective, from our API, you will be able to, for each of the clouds that you have registered in your dashboard, you could have many clouds, or you could have only just a few Amazon regions or one region. Okay? For any of those, you can now create multiple networks. We use the term networks, not VPC. It's more generic. Okay? Each of these networks, again, is a perimeter, and everything that goes in and out has to go through the gateways. Now, these will map differently depending on which cloud this thing is underneath, right? Inside the networks, you can create subnets. So we use the term subnets instead of tiers, for example. Each subnet may be bound to a data center. Data center is RightScale abstraction of an availability zone, right? We don't call them zones. We don't call them availability zones. We call them data centers, but it's the same thing. It's just the name. Okay? So each of the subnets may be bound to a security group, a data center, or may not be bound to a data center. Because in the case of Google, those things are not bound to data centers. So depending on the cloud, you may have an optional parameter that says, I want to create it in this data center, and some clouds obviously won't support being bound to a given data center. Subnets will have network interfaces. We don't call them elastic network interfaces. We just call them network interfaces. And then you'll be able to continue using security groups as you have right now. With the exception, you'll see that those are related to the network interfaces rather than directly to the instances, because an instance can have multiple connections through multiple network interfaces, and each network interface can have multiple different types of security groups associated with them. Routing tables and network ACLs. So from a RightScale perspective, you can launch an instance. You can say, I want it in this data center. I want it to be connected to one or multiple network interfaces that already exist there. And you want to say how many security groups are each of these guys associated with. OK, so if you step back for a moment, this is just what happens within this networks sub-resource, right? But this is framed by a cloud. So there's other things that the API exports that you probably are using right now if you use our RightScale API. We have images, volume snapshots, volumes. Some volumes can be bound to a data center. Some volumes they don't have to be, like in Google. Okay? And that's the typical thing that we already support. Now, one conspicuous thing that is not here is IP addresses. Right? So you may be thinking, where does that fit in? Well, we do. There's an interesting thing here. So you're going to have a set of IP addresses available, and those are just IP addresses that you can use to connect instances. And then we have an abstract, and that's cloud region or cloud level, right? There's a set of IPs that are bound to that cloud. And then within each of the networks, you can get a binding between an IP address that exists in the cloud and one instance or one network interface for a given network, for a given subnet. So the IP address bindings is the connectivity or the abstraction that tells you that through the API allows you to say, I want to use this IP with this instance or with this network interface of this instance. And what I want to say there is that rather than just exposing these IP address bindings as simple just IP connections, we expose IPs and ports. So that way you can do the following. You can say, I want to do an IP address binding that maps IP A to instance 1. All IP traffic, please send it to that instance. That's one way you can use this. But you can do things like, I want to bound this IP address A ports 80 and 90 to this particular network interface of this instance. So the binding could be seen as just the IP, every port of the IP, or only some ports of the IP. And that will be mapped to whatever constructs the cloud provides. Some clouds allow port forwarding rules, which will be the port range forwarding. Some don't. But if you use the same abstraction, you don't have to worry about using one way or another. In a sense, you can think of, if I want to say, I want to map an IP address A to instance 1, the all IP colon star, like all ports. In a way, you can think of that. You may or may not specify which ports you want. So that's something else that also, I think, might help in terms of consistency. Okay. So that's all good. That's what we're going to start exposing. So how do you get to use that? So that's the next part I want to show you. This will allow you to, through this API, and I'll show you some UI screenshots, you'll be able to see all your network infrastructure from a single pane of glass. Everything is aggregated. So you'll see what networks do I have in my account. Some networks may be spanning different, not spanning, but belonging to different clouds. But you may not care. Your application may just care about which networks exist. I don't necessarily want to see what networks do I have in region 1. What networks do I have in region 2? I just want to see my networks. I mean, obviously I can filter by, I can sort, but the networking is one piece. It's an aggregated stuff. So with this, you can have people that are network operators or security operators that can go to that interface, UI or API, and create and manage all these resources independently from the operators that are going to actually use them. You're going to have people designing these things. You're going to have people using these networks and these network interfaces. So just some screenshot. Oh, that's not very nice. OK. Well, if you squint a little bit, you can get the feel of what this is going to look like. So in the UI, so you will go to Design and Network Manager. And this is an example of, every row will be a network. Okay? So you can see the network. You see some descriptions, the CIDR blocks, and things like that. And then so you cannot really see it, but in my mock-up example here, you have the third column is the cloud. You'll see that some networks belong to AWS, East, West. I have a private cloud. I have a GCE. So really, it's the aggregated thing of everything you have in your account. If you click on a particular network, then you can see several things about that network. So I'm going to have, I think I have one screenshot for each of the tabs. One is Info tab, generic information about the network, description, and things like that. Second tab is the subnets that exist in that network. In this case, I have 3 subnets, something I made up like app servers, front ends, and storage, as a way to maybe separate the different tiers that you have, the CIDR blocks and stuff like that, the data centers that they belong to. The next tab will be the security groups. This is you can obviously create subnets from this interface. The next tab is the security groups of that subnet. You can see them. You can see the rules. What you would expect probably from the point of view of a UI that gives you the visibility into these resources. And we even have an audit entries tab, which allows you to see what are the things that are happening in my network. And this is all being designed, so if you have a particular feedback about, oh yeah, I would like to see this type of audit entry things so I can monitor whatever you need to monitor from this interface. So we'll be happy to get that feedback. So that's what's coming from the UI perspective. How does this look from the API perspective? Probably, if you're using our API, it should look very similar to you. It's a RESTful API. It's multi-cloud. So you can do things like for simple resources like a network. Well, it'll be as simple as posting to the networks. I'm simplifying here some of the parameters here. But posting to the networks API, passing the name, the CIDR block, the cloud that you wanted to create under, because you may have several clouds in your account registered. And then that's it. You get a network extend. You created the network. Depending on the cloud that you asked us to do it, that will have mapped into creating a VPC in Amazon or a network and a tier. Well, not a tier. This is a network. An isolated network in CloudStack or simply a network in Google. Right? We will take care of that. A little more, I guess, complex example is how you start using these things in your servers. Because now when you launch a server, you want to say, hey, I don't want to launch a server anywhere. I want it to be in this network, in this subnet, with these bindings. So that's an example of what you would need to do. Right? For example, apart from the cloud settings, the server template, the inputs, and everything else, you may want to configure the server. Right now, you will be able to say, I want this server to be attached to this network, which I've created before. I want these subnets to be bound to this guy, and these are the security groups that I want it to be bound. For example, this is one way to say, for each of the subnets that I want it to be bound, apply all the same security groups, right? Replicate. I want the same security groups bound to both networks. Same thing. You get a 201, you get a server, and now you can launch it. You can do whatever you want in the normal way that the API allows you to do. Again, remember that this will be mapped to whatever the right low-level abstractions exist depending on the cloud. And then I have another example of the IP binding sports that I was telling you guys about. You could create a binding, which means I want to create a connection between an instance and a public IP that I have in my account. And then if I don't specify the ports, the two parameters, that means I want to create really a binding of all the traffic of that IP between the public and the private interface. But if I specify the ports and the cloud supports it, I'm creating a binding only to a few ports. But it's the same resource. So you think of an IP address binding as a meta resource that understands ports if you want to understand ports. OK, how are we doing on time? Too fast. OK. Hope you have a lot of questions. Then I'll get into this thing later. Just one note here. I haven't talked about routing tables and network ACLs because we're still designing that, but that's the next thing that is coming up. Okay. Then let me talk about this for a moment. Synthetic resources. So there's an interesting subtlety in trying to create an API that is consistent across clouds. And that is, for example, that if you build your client, the API clients, to know how to start servers and how to define what connections I have, it's probably bad practice if we told you that depending on the cloud, you're going to have to specify security groups through the network interface, and depending on which cloud, you cannot have network interfaces, therefore you just tell us the security groups. That's sort of creating clients that are unnecessarily complex. So for some of these cases, what we're going to do is we're going to create some, I call them synthetic resources, that somehow map to something that the cloud does not have, but it's implicit. So for example, let me give you an example that probably will be clearer. Remember EC2 Classic. EC2 Classic does not have subnets. It has security groups. So I have two options here. Either say, when you launch a server, you just tell me the security groups, and I'm going to make it happen. Which means that then when you launch an EC2 Classic, you will know that you have to pass some parameters different because there are network interfaces and subnets don't exist. Or I can say, you know what? What we're going to do is we're going to create a subnet, a synthetic subnet for you. We're going to create a subnet for each of the availability zones, and you pass those same resources to me when you create the server. That way you always pass these parameters in the same way. You know that this synthetic subnet 1 won't have a direct mapping into a real resource in Amazon, but conceptually, that's what you want. So we allow you to do these things in a much easier way, so you don't have to have the clients do too much crazy stuff, right? Note that this is important even if you're just using Amazon, right? Because you may have some legacy code that works on EC2 Classic, and you're starting to launch new infrastructure in VPCs. The way that you build your client is going to be exactly the same thing. And over time, maybe you move off these synthetic subnets, and everything is new. So that's an interesting tidbit that may not be clear until you start using it, but hopefully this helps. And here's my summary slide. So maybe before the summary, maybe we can open up for questions if you have them. Do you guys have mics? Perfect.
So two questions. Number one, I think you may have answered with the synthetic resources. So what happens if when you do a common API across all the clouds, you have to kind of choose the lowest common denominator, right?
No.
So I'm trying to understand. So the two questions: A, like you said, if you provide things that the underlying cloud doesn't provide, can you talk a little bit more about how that your synthetic resources actually help? Because how do you bridge that gap? And the second question is, what if there are networking features that you haven't abstracted? So in the classic virtualization domain, they talk about pass-through. So would a customer be able to do a pass-through and get to the underlying network resources? So they use most of your API for your networking infrastructure, but for this one, they go, you know what, I really want to use the Amazon thing, natively. So those two questions. Thanks.
Yeah. So actually, they're very good questions. Maybe I was not clear before. Let me try to answer both questions with the same thing. So when I talked about synthetic resources, I don't mean it sound like that everything that exists in our API will have a synthetic resource for you to use. What I wanted to bring up is that there are certain ones that are so front and center, like subnets, that we wanted to have it there for you so that you don't have to, manage these differences for something that you're going to do every day. Now, for example, that doesn't mean that I'm going to have a firewall resource for EC2 Classic that somehow translates things into security groups. That's not what I'm saying. If you're in EC2 Classic and you try to create a firewall, it's going to fail. It doesn't exist. There are no firewalls, right? So the synthetic resources are not something that everything will be wrapped around and somehow translated. No. If a cloud does not support routing tables, we won't magically support routing tables. So that's one thing. The other one about the common denominator, it's very important to, maybe I didn't stress it enough at the beginning, we don't want to have an API that waters down what the clouds can do. We want to have something that is consistent and easy for you to use. But when you need to go down into the guts of specific things, you can do it. And in the API, for example, you will be able to pass cloud-specific parameters that only would work if the cloud behind it is the cloud that supports it. So there's some things that are optional here that may or may not work depending on the cloud. But you will be able to take advantage of them. Because if we don't do that, this is useless. You need to be able to use the exact power features of each of the clouds whenever you want to.
Right. So going back to the first answer, so in other words, what you're saying is your API, you won't provide an API against a cloud when the cloud doesn't actually offer that type of resource or feature.
Correct.
So you never get I call this API, and then the cloud, basically throws up and go, what the hell is this?
Right.
So that won't happen, right?
Right.
Got it. Okay.
Yeah, and then it's a fuzzy line, I guess, because, for example, look at the IP bindings resource. IP bindings resource really is a combination between static NAT. So if you say, I want to map this IP to this instance without ports, we will use whatever static NAT capabilities the cloud has to map the whole IP. But if you want to say, I want to map certain ports, we will translate that into port forwarding rules or whatever the capability of the cloud has. So this one, you can think of a resource that encapsulates two different types of resources behind. But the opposite is not, it's not the case, like you're saying. We want to expose something that doesn't exist in the back. We're not in that business, right? Question, yeah.
How do you handle a case where you don't have a network abstraction for elements that are supported in a cloud? Let's say like a load balancer, you don't have abstraction today. So in the case of where you're trying to create that service, what does the user have to do?
That's a good question too. I'm not sure what we're going to be doing in the future to perhaps involve these other abstractions more front and center here. We're working on adding new types of resources that you can plug into the cloud capabilities, like ELBs, say, if you wanted a load balance for Amazon. Right now, we don't expose it, and the only way to solve that is through maybe launching servers that have that capability, load balancers. But our API does not plug into every single service that all cloud providers have. Like, we don't have EMRs, we don't have DynamoDBs, we don't have ELBs or RDSs. We have some, but in a different, not in the API, from the UI perspective. Now, I think in the future, there's certain things that are generic enough and very important to users that we may want to add in some way through our API. But being honest, we haven't thought about that quite yet.
I guess two questions. One is, if we're using the API and we create an object using your API, how do we then reference it with the specific calls for AWS or whatever? Does that make sense? So
if you're creating, say, a subnet through our API, how do you reference it?
Yeah.
From our API, it's all about hrefs. Oh, you mean how do you know which
How do I know
resource in the
which
cloud?
Amazon resource I'm addressing with the Amazon specific code after I've created it
Right.
using the RightScale interface?
I guess it depends on the resource. Like networks and subnets have names. So the name that you said, you'll see it in the Amazon console if you go to the Amazon console.
Right, in the
Not all of
console,
them.
I guess, but your API doesn't return it directly?
Oh, it does. It does.
Oh, okay. Sorry, I missed.
Yes.
I haven't used it before.
It was probably not visible. Do I have any? Let me see here. See the second column, resource UID?
But in the REST call that you had, it's not in there? Or if I just create a subnet and then immediately want to address it in the next API call?
Yeah, it's our
It is there.
hrefs.
Okay.
So
Okay.
here, let me show you here. Networks, right? I created a network. In the normal REST interface, you'll get the href of the network that you created. So if I want to manipulate that network, that's the network from the RightScale interface.
Okay, I think I get it. And then if you want to do port forwarding, for example, for port 8080 for this instance and port 4040 for some other one, in some networks, I guess, in some clouds, that would be possible because it's port forwarding.
Mm-hmm.
But if you're emulating a port forwarder on a network that doesn't support that, what would
fail.
happen?
It would fail. That's kind of, maybe it's not clear enough, but we won't magically do stuff behind the scenes that the cloud does not support. So if you try to set a port forwarding rule in Amazon, it will fail because they don't support it, right? At least right now. Doesn't mean that if something is so popular, we could potentially do something on the back end that somehow is more intelligent about choosing what to do. But right now, what we want is you to have a common interface in how to manage all your, not just servers, but the network infrastructure, but at the same time be able to use specific cloud things. If something is not existing, we want to make magic kind of thing, at least at the moment.
So a follow-up to that is your API smart enough to say, to identify the parameters that's not supported for a specific type of cloud?
Correct.
So it provides a guideline, general good guideline for each of the different cloud.
Right. It's a consistent way to do it, and then we take care of the mapping. We don't take care of the magic. You know, we won't be able to allow you to do firewall rules in a cloud that has no support for firewall rules. We will know, oh, you try to do that in this cloud, it's not allowed, so it's going to fail. But at least the way that you're programming your client, it's the same for all clouds if they support it. It's not magic.
So there's a lot of talk about software-defined network. So how does that? I mean, is this a standard? First of all, is software-defined network a standard first, and then how does this play into it?
Good question. I don't know how to answer that. What this tries to do is simply make consumption of what the cloud provide in a much palatable way. This is not a standard. This is one way for you to use this. Who and how we support SDNs, I don't know. I mean, at this point, we're just trying to allow you to use what's out there, whatever that is, SDN or not SDN, right? So,
have you given thought to encryption, network level encryption between clouds?
no. So that's a good question too. So that opens up another the magic door kind of thing, right? So once you have some common interface, we can start adding value on top of what the cloud provides. So kind of what you were saying, like saying, if you want to use a feature that the cloud does not provide, we're not going to do magic. But we could do some magic as we move forward and understand that if you want to connect, I hope that there's no salespeople around here. I'm just saying, potentially, we could have an abstraction on top of this that says, is a multi-cloud security group or multi-cloud firewall. And we know enough to potentially say, you want to connect that instance in that cloud, in that subnet, to that instance in that cloud, in that subnet. We could potentially do something that allows that to happen. Create a VPN, create some firewall rules here and there, open up the IGWs and things like that. We don't do that right now, but again, if that's something that is extremely useful to people, we could potentially think of putting another resource like a multi-cloud security group or connection on top that is more intelligent. But that's where the magic would come in. We would add value to things that cloud don't support.
So two questions. So what you've shown today is the administration, the creation of the network or the underlying cloud network, right?
Mm-hmm.
And I see the abstraction. But from an ongoing usage perspective to consumption, so I have a VM now that this VM wants to use this network. Are you also providing the abstraction for the consumption piece as well?
Yeah, you mean like when I create, for example, when I create an instance, a server,
that I want to associate that.
Yes, that was this abstraction, for example. We have both instances and servers, but server is basically a glorified instance.
Right, so your API covers administration as well as consumption.
Yes,
right.
This is directly tied into the API that we have already right now that allows you to create servers, manage them, terminate, change them on the fly, and all these things. So this was a quick example that to basically say that now you can also, when you create these instances, you can specify where to connect them to.
Right.
It kind of ties those together.
Right. The following question may not be, super relevant to our discussion here today, but now that you have provided abstraction on top of networking, what about storage, right? Because different cloud provide different types of storage, S3 versus Google Compute Engine, blob storage, and whatever it may be. Is that something that you guys have today? If you have and I miss it, I'm sorry, but if you don't, is that something that you can consider?
I guess there's two parts I can think of that to answer that. Number one, we don't have anything right now that abstracts object storage. Pure object storage like S3, cloud files, that type of stuff. We allow you to use it. We have UI and everything. You can use it. But we don't have an API that abstracts that. The flip side, though, we do have an API for what we call volumes, and volume attachments and volume snapshots. Right? That is in the same way that this is abstracting different clouds. I think I had a down here, right? This is already existing right now in the API, this part right here. So we call a volume something that it's kind of a disk, something you can attach to an instance and detach. So that you can already manage multi-cloud with our API. So the object store versus the disks, they're two different things. We don't touch the object store from the API, at least now. We do provide you with snapshots and volumes and all these things across clouds. And some clouds are quite different. Like if you want to create a volume in Azure, there's a few steps that in the back have to happen. You have to create the storage. You have to, so that exists. No more questions? Okay, so let me wrap up the last slide really quickly. So I guess that my main point here was to show that, or to make the case that, these things are kind of messy. And if you've dealt with them, you probably already know. But this mess is good because it gives you choice. Now the question is, where do you want to spend your time with this choice? Do you want to spend your time in really needing to be an expert on every single detail and understand every single API and when they change over time, even if you're not in multi-cloud, right? If a given cloud changes quite a bit. And if you guys have had to deal with Amazon, even if you're just Amazon, the change from Classic to VPC is completely different, right? It opens up a whole bunch of new API calls. So with these abstractions, what we want to allow you to do is to operate all these things from a single pane of glass, make you think a little bit at a higher level abstraction, but without losing this, without the common denominator thing, right? We want you to make it easy when you don't care about the details, but give you the power when you care about the details. So that's something that's always very important to us because otherwise, this doesn't work, right? If, from the server's perspective or the volumes, if I want to launch a server with provision IOPS in Amazon, I want to launch a server with provision IOPS. I know that no other cloud allows that, but in our API, you can have a cloud-specific parameter to allow you to do that. So that's very important to us. So I would say give it a try. This is going to come up soon, at least the first set of resources. And see if it allows you to manage your cloud resources more consistently and over time. So we will take care of a lot of these things for you. So you can kind of focus on your business more and less on the dirty details of the APIs, unless you really, really like these APIs. And that's it. So if there's more questions, I'll take them. If not, we can wrap it up. I guess we can wrap it up. Thank you.